I'm your Komali ma'am. In this session, I'm going to teach you all electronegativity simply. By using a simple tricks, how can you solve the question? Watch this video till the end. Begin the session. Before going to start, trick number 1, just I want to tell you what do you mean by electronegativity. For example, here we have A and B. Okay, let's say this is A, this is B. Now A gave 1 electron and B gave 1 electron. Both shared the 2 electrons and formed a bond. A bond B. See, A bond B. Now, if B atom has more tendency to attract these 2 electrons towards the B, then B gets which charge, students, tell me? Partial sign is del, partial negative. A gets a partial positive. See, the tendency of an atom to attract the shared pair of electrons towards itself, we call it as what? Electronegativity is, let's say CD is there. If C is attracting these 2 electrons towards the C, what charge C will get? C will get negative charge. D will get a positive charge. Which has more tendency? That will get the more negative charge, that is more electronegative atom. Fine. Now coming to the trick number 1. What I am going to teach you is an excellent trick. If you like it, you should give a heart to this video. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Right? These elements you know, na? Next, sodium, silicon, phosphorus, sulfur, chlorine, argon. These elements, zero electronegativity, no need to write. Now coming to this elements, worrying how to remember these electronegativity orders. No, I am going to tell you excellent trick. Just to see, lithium start 1. Add 0.5 to this. If you add 0.5 to this, what you will get? 1.5. Add again 0.5 to this, 2, add 0.5, 2.5, just add 0.5, 3, add 0.5, 3.5, add 0.5, that's it, easy to remember, no, just you added 0.5, my dear students. Next one, from sodium you begin, sodium 0.9, okay, remember the first value. From here, add 0.3 difference. How much you need to add? 0.3. Just so 0.3 you add 1.2, 0.3 you add 1.5, 0.3 you add 2.1, 0.3 you add, what you will be getting? 2.4. So, but up to here only this is applicable. You have to add 0.3. Here you add 0.4, you will get 2.5. Here you add 0.5, you will get 3. Okay. 1.5 plus 0.3, how much? 1.8. You are thinking, no? Yes. Next, 2.1. Until here, 0.3 is the trick. Okay. Here, just add 0.4, you will get 2.5. Add 0.5, 3. This is the trick to remember the electronegativities. Different electronegativities. From this, most important question all come from this table itself. Okay. Fine. If you observe carefully, left to right in the periodic table, left to right, what is happening to the values? 1, 1.5, 2, 2.5 means increasing. So, here trick number 2, I want to tell you that left to right, electronegativity values are increasing. But top to bottom, students, if you see the top to bottom, like for example lithium, sodium, in that family top to bottom, anomalous will come, but usually top to bottom, what's happening top to bottom? Electronegativities are decreasing. So left to right increases, top to bottom. One small tip I want to tell you, size is inversely proportional to the electronegativity. Simply left to right, size decrease. So nucleus has a more power to attract the electrons outer, that bonded electrons. So electronegativity increases. Why it increases, how it increases, normally we will see in regular class. Here, how you can solve the question is, for example, I will give you boron, carbon, nitrogen, oxygen. They will ask you give the electronegativity order. What do you say? Left to right, electronegativity increases. Easy. And here one important exception I want to teach you. Top to bottom electronegativity decreases, I told you. But boron family is an exception. You see boron, aluminium, gallium, thallium. If you observe, start from here 1.5. Here 1.6, 1.7, 1.8. Top to bottom, what's happening to the electronegativity? Electronegativity is increasing. Increasing. This boron is, what is the electronegativity of boron? 2 is the electronegativity of boron. It comes here in its exception. Got it? Fine. Another simple trick I want to tell you. This trick, maybe it is like funny, but just, observe it. Sometimes they will give this mixture, combination they'll give you. Okay, I'm going to give you a test yourself question. Fluorine, oxygen, chlorine, sulfur, like that they'll give. See the trick. Like inverted Z is the order. Fluorine, oxygen, chlorine, sulfur. If they give this family, how you solve? Oxygen, for example, they are giving the combination oxygen, nitrogen, phosphorus, sulfur, they mixed and they gave. How you will solve? So inverted Z is the trick. See, inverted Z is the next, inverted Z is the, up to here only it's applicable. So any combination let them give. For example, they're mixing fluorine, chlorine, sulfur, oxygen, like this. What you write the elements? If you don't remember these electronegativities, I'm telling you, simple trick. Fluorine, oxygen, chlorine, sulfur. So fluorine highest, oxygen, chlorine, and then sulfur. Easy. Next, if they give oxygen, nitrogen, sulfur, phosphorus, how you will do? Z, inverted Z, like this. Okay, oxygen, next nitrogen, next sulfur, and then phosphorus. Easy. Remember these values. First one is 2p elements are 0.5 difference. Third period elements are 0.3 difference up to phosphorus, then 0.4 difference, then 0.5 difference. That's it. Anything you will solve very, very easily. And under trick number 7 here, I want to tell you few formulas which usually students feel confused about these formulas, how to read. I am going to tell you here. What is that is, Mulliken is the name of the scientist. He gave a formula for finding the electronegativity. What is the formula is? Mulliken's formula is, electronegativity on Mulliken scale is ionization potentials plus electron affinity values. If you take, what is ionization potential? The amount of energy required to remove an electron. What is electron affinity? If you add an electron to an atom, how much energy it releases. Usual class, I'll teach you slowly. Ionization potential means what? Amount of energy required to remove an electron. Electron affinity means if you add an electron, some energy releases. The sum of these two, average if you take, that is called as electronegativity on Mulliken scale. But Pauling is the name of the scientist. What he told is, hey Mulliken, you have taken the electronegativities based on ionization potential and electron affinity, but I will take based on the bond energies. He has taken based on the bond energies, and he has given a relationship like, he has given that electronegativity on Pauling scale is equal to electronegativity of Mulliken scale divided by 2.8. This is a relationship he has given. Actually, from this the formula we got is like, this is actually the formula he has given. Okay, 5.6. This is the formula he has given. How we got from this to here? This is ionization potential plus electron affinity divided by 2 into 2.8. And ionization potential plus electron affinity divided by 2.8. Ionization potential plus electron affinity divided by 2 is what, students? Divided by 2. This is electronegativity on Mulliken scale. So divided by 2.8 is equal to electronegativity on Pauling scale. This is a formula This is the formula to find electronegativity on which scale? Pauling scale. But this is the formula to find electronegativity on Mulliken scale. Both are different scales. What is that? Both are different scales. They are different scales. This is considered based on ionization potential and electron affinity. This is considered on bond energies. But from this we can use this formula. But this formula is applicable when we use values under electron volts. For example, if not electron volts, if these two values we will use in kilocalories, then the formula is plus electron affinity divided by 125 is the formula. Which formula this is? This, if you want the units, if units are in like kilocalories. Suppose if the units are in kilojoules, then the formula is ionization potential plus electron affinity divided by 540. This is kilojoules per mole. When these two values are in kilojoule per mole, use this formula. When these two values are in this, use this formula. When these two values are in electron volts, then use this formula. This can be anything, but this is different scale. Everybody clear? Got the clarity? Now let us see questions how fatafat you will do. You have to answer, okay? Here one excellent point I want to tell you. Left to right, what's happening, students? Electronegativity increasing. If electronegativity increase means the element is having a tendency to attract the electrons, that is called as non-metallic character. What is this nature? Non-metallic nature. If non-metallic nature increases, we can say that acidic strength increases. Simple trick. Acidic strength increases. Easy, no? Now, see how you will solve left to right. What's happening to the electron? Nitrogen. Okay, solve this question fatafat. Tell me. Nitrogen, carbon, boron. What is happening to the electronegativity? Boron, carbon, nitrogen. Which is having more electronegativity? Nitrogen. Electronegativity increases, acidic strength increases. So which is more acidic oxide? Which one is having more acidic strength? HNO3. Then just to see the element, central element, okay? Nitrogen, carbon and then boron. Next one. Chlorine, bromine, iodine. Top to bottom, what happens to the electronegativity? Electronegativity decreases. So acidic strength also decreases. Easy, right? For example, sulfur, selenium, tellurium. Top to bottom, what happens to the electronegativity? Electronegativity decreases. So acidic strength also. Let's try next question. Fluorine, chlorine, bromine, iodine. Top to bottom. Simple. Just take the element. Nitrogen, phosphorus, top to bottom electronegativity decreases, so acidic stress. Easy, students. Then give a heart and let me know in comments how was the video. Phosphorus, arsenic, antimony, top to bottom. Next, nitrogen, phosphorus, arsenic. What happens to, see, based on just one point, see how many questions you are solving. Sulfur, selenium, tellurium, top to bottom. For this, you should know the element which group you top to bottom na, left to right na, that you need to identify. Fluorine, chlorine, bromine, iodine, top to bottom. Now, I am going to give you two test yourself questions, okay? One question I will solve, one question you solve, one more test yourself question I will give you. For example, correct order of electronegativity of these elements, how fast you will solve. Tell me. Boron, carbon, nitrogen, oxygen, fluorine, aluminium, silicon, sulfur, phosphorus, sulfur, chlorine. Now write the elements, circle it. Which elements they were asking? Silicon they were asking, carbon they were asking, nitrogen, phosphorus. You did not write the values. Just what I told you, remember inverted Z trick. What is the inverted Z trick? That's it. Nitrogen, then carbon, then phosphorus and then silicon. Option 4 is the correct answer. Even you can write the electronegativities which I have given and check it out and solve any question. Okay. Try this question. Let me know your answer in comment section. One more question for you. See, this is a question. I have given ionization potential and electron affinity values. I want your answer in Mulliken as well as a Pauling. Okay, then tell me what is the formula we will use, students. Tell me, will you try this? Mulliken scale electronegativity, what is the formula? And Pauling scale, what is the formula? Try this question, total 2 questions. Try this and let me know your answer in comment section. Thank you so much for watching this video. See you again in next video. Have a great day.